Hi everybody, today's lesson is lesson 41 and it's finding the percent of a number. This is a really important real life math skill to understand how to do for lots of reasons, but without further ado, let's take a look at our learning targets for today. Number one, write a percent as a decimal. Two, find the percent of a number by changing the percent to either a fraction or a decimal and then multiplying. And then the last one is to calculate the sales tax on a purchase to find the total price of the purchase, including tax. So, right there, super important real life math skill. What I love about this math topic or this math operation in general is that it's one of those ones that really you can personalize and do solve however makes sense in your brain. So when you're finding the percent of any number, you can solve that by either finding going the fraction route or the decimal route. Both will get you the right answer. Both will get you there. Just depends on what works better in your brain, what seems easier. Of course, in this video today, I am going to go through both ways of solving both the decimal route and the fraction route, and you can decide from there which one you prefer. Taking a look at some notes here, I've gone ahead of time and drawn some things in and written some notes, and I'll kind of talk through those with you. So another error here, sorry, disregard that. We have percents to decimals and to fractions. I'm going to break down a little bit what that means. So when we're looking at a percent, for example, we have 25% right here. 25, anytime we're talking about percents, we're talking about a number out of 100. So that's where this first fraction came from. We just simply start by writing 25 out of 100 or 25 over 100. That's all that represents. From there, we are going to be writing that as a decimal and as a fraction. So let's go back to this really quick. 25 out of 100, the way that you would read that fraction is 25 hundredths. And if we can say that fraction, we can write the decimal easily because hundredths is also a place value when we're working with decimals. It's two places past the decimal, or what we would call two decimal places. So 25 hundredths also looks like this. This here is read as 25 hundredths, and that's because my 25 ends in the hundredths place, two places past the decimal. 25 hundredths, 25 hundredths. Those both say the same thing. If we are going to write 25% as a fraction, it's important that we remember fractions are always, especially from this point moving forward with your fraction work, they're always written in the simplest form. So it's important not to leave it like this. We need to simplify this fraction. And of course, 25 hundredths can be simplified. This fraction can be reduced down, and it reduces down to 1/4. 25 and 100 both have a common factor of 25. So 25 divided by 25 gives us the 1. 100 divided by 25 gives us the 4. 1/4 would be our fraction. Taking a look at another example here, I've already written in the work, but I'm going to talk through it. So if we're looking at 5%, we start by thinking about this as 5 out of 100. Anytime we think of percents, we think of out of 100. So 5 out of 100. Now, when we look at that same thing we just wrote and think about it like how I would read that as a fraction, we would read that as 5 hundredths. 5 hundredths can also be represented in a decimal number because hundredths is a decimal place, two places past the decimal number. Our 5 must go in that hundredths place, or this number must end in the hundredths place. So make sure not to write your 5 if you're thinking about how this would look. Your 5 would not go here. This is the tenths place. 5 hundredths looks like this. The 5 is in the hundredths place. So that's our decimal number that represents 5%. And now if we're thinking about the fraction that represents 5%, of course, this is a fraction that represents it, but it's not in the most reduced or simplest form. We need to reduce from here. 5 hundredths can be reduced down because 5 and 100 both have a common factor of 5. That means they both can be divided by 5. So if I take 5 divided by 5, I get my 1. And if I take 100 divided by 5, I get 20. Anytime you're left with a fraction with 1 in the numerator's place, you're definitely all done. So our most reduced form of this fraction that represents 5% is 1/20. Let's take a look at this example. Write 15% in decimal form. Unpause your video when you're ready to check your work with mine. All right, so I'm going to start by doing that fraction thing. I'm going to set this up over 100. So 15% is the same thing as 15 over 100, or 15 out of 100. And from there, if I can read this setup, if I can read this fraction, I can write it as a decimal very easily, which is what they're asking us to do, decimal form. 15 out of 100 is read as 15 hundredths. Well, hundredths is a decimal place, 2 places past the decimal, so it needs to look like this, 15 hundredths. Take a look at example number 2. Write 75% as a reduced fraction. So give this one a try. The previous slide was a decimal example. This one's a fraction example. Unpause your video when you're ready to check your work. So the first thing that I'm going to do again is set this up over 100. That's how percents work. 75% is 75 out of 100. Write this as a reduced fraction. Well, 75 hundredths is a fraction, but we need to reduce that. We definitely need to reduce that down. So if I'm thinking about the numbers 75 and 100, I need to start thinking about what would be ultimately I'm looking for the greatest common factor that saves me steps and makes my math quicker and simpler. But if I can't think of what the greatest common factor is, I could at least think of a common factor. Here's what's coming to my mind right now. I know for sure that because both the numerator and denominator end in a 5 and a 0, I know that I can use the number 5. 5 will definitely be a common factor that these both have. But I also happen to know, I'm thinking in terms of quarters. I can't help it. 75 and 100 also have a common factor of 25. So if you think about quarters, 75 is 3 quarters. 100 or $1 would be 4 quarters. So let's think in terms of 25. 75 divided by 25, and I should really write that down for notes purposes. Let's divide by 25 and use that as our common factor. 75 divided by 25, like I said, think in terms of quarters. That leaves us with 3. And 100 divided by 25 is 4. 3/4, we can't reduce any further than that. 75% as a reduced fraction is 3/4. So now this is kind of taking this a step further now. What number is 75%? Oh my goodness, this slide is full of typing errors. What is 75% of 20? So I'm not going to go through an example before asking you to try this. Please go ahead and try this if you feel comfortable. You can solve this by going a fraction route or a decimal route, and in a moment, I will talk through how to do both ways. Unpause your video when you're ready to check. All right, so because we just solved 75% as a fraction on the previous slide, I remember that 75% as a fraction is represented as 3/4. So this is starting to solve with the fraction route. I know that that's represented as 3/4 of in math. I'm looking right here. What number is 75% of 20? Remembering that this word right here is a math term. And anytime you see the word of in math, it means to multiply. So right here, I have 3/4 times 20. Now, when I'm working with fractions and I'm given a whole number, any whole number can be a fraction instantly. All I have to do is put that whole number in the numerator's place and add a 1 as my denominator. It's the same thing. You're really not changing the number at all. You're just changing how it looks. So 3/4 times 20, or 3/4 of 20, is the same thing as 3/4 times 20 over 1. Now this is just a multiplying fraction problem. I could cross reduce, and I guess I'm going to use this opportunity to remind you on how to do that. I'm going to look at numbers that are diagonal from each other. 3 and 1, I can't reduce anything there, but 4 and 20, I definitely can. They have a common factor of, I want to give you a chance to just think about that for a second. 4 and 20 have a common factor of 4, right? So 4 divided by 4 is 1. 20 divided by 4 is 5. Now I have simpler math to do as I'm multiplying across. In my numerator's place, I have 3 times 5, and that gives me 15. Denominator's place, I have 1 times 1, and that gives me 1. When you're providing an answer or a product to a fraction multiplication problem, this is not the simplest form. You never want to actually provide your answer like that. Setting up a whole number as a fraction like that works for solving purposes, but don't leave your answer like that. So anytime you have a 1 in the denominator's place, just get rid of it. 15 over 1 is the same thing as 15. Now let's stop and ask ourselves if that's reasonable. What number is 75% of 20? Or what number is 3/4 of 20? 15. Yeah, that totally makes sense. Now let's solve this as a decimal. What number is 75% of 20? Well, one moment, my lights shut off, I'll be right back. So when I go to think about this for solving this as a decimal problem, I need to determine what does 75% as a decimal look like. So I start by envisioning, I could even write this out. I'm kind of running out of room because I write pretty big in math. But I start to think about this again as 75 over 100, 75 out of 100, or 75 hundredths. And once I say that, I know exactly what this needs to look like as a decimal. 75 hundredths means my 75 ends in my hundredths place, which is 2 places past the decimal, or 2 decimal places, we would say. 75 hundredths looks just like this. So again, in math, the word of means times. So 75% times 20, or 75% of 20 looks like 75 hundredths times 20. Multiplying decimals is also something that we just recently practiced as a math skill. So you're going to multiply like normal and then determine where your decimal point goes. So we have, if we go through this whole process here, we have 0, 0, 0. So bear with me a moment. 0, 0, 0. I've done my zeros. I'm going to, there is actually a faster way to multiply this. We could just add the 0 at the end, but whatever. I'm going to go through the process of showing you. We need a placeholder here. 2 times 5 is 10. 14, 15. I'm running out of room here. We have, I'm actually just going to write this right up here. 0 plus 0 is 0. 0 plus 0 again. 5. This is a 1 and a plus sign. So we have a 1 here. Determining where our decimal goes, we go back to our original problem and count back decimal places. We have no decimal places here, but we have 1, 2 here. So let's go to the back of our answer, the far right, and count back 2 decimal places. 1, 2. In dealing with decimals, the most simplified form of providing a decimal product or a decimal answer in general is if you don't have any counting numbers after the decimal in the decimal places, if those are all zeros, don't bother showing the decimal at all. Instead of writing 15.00, we're just going to write 15. So, ta-da, you can see that either route, fraction or decimal route, we've both arrived at 15. Whatever's easiest, decide which is easiest to solve and solve. Both will get you the right answer, depends on what is your preference. Give this a try. I encourage you to try both ways because it will take some practice in doing both methods to determine what you like better. You might have an idea already, but still important to challenge yourself to do both ways. Jamal correctly answered 80% of the 25 questions. How many questions did he answer correctly? Please give this a try. I challenge you to try both methods, fraction and decimal, and unpause your video when you're ready to check your work. Let's start by solving as a fraction. So 80% looks like this. We're going to start by seeing 80% as 80 out of 100, right? Something to note, and I've mentioned this before, but it's worth saying again, anytime you see a fraction like this where the numerator and the denominator both have a 0 on the end, which they do right here, we can simplify this really quickly by chopping those both off. So instead of 80 over 100 now, I have 8 over 10. Still needs to be simplified a bit, but it's a lot easier to think about in your head. So now we have 8 over 10. That also can be simplified down. If I'm thinking about a common factor they have, I see that they're both even numbers. I definitely can divide by 2, so why don't I just start there? 8 divided by 2 gives me 4. 10 divided by 2 gives me 5. Once I see my fraction of 4/5, I know that I can't reduce that any further. That's the fraction I'm going to have to work with. So I've figured out what 80% is as a fraction right here. And now I need to continue to do my work. 80% of the 25 questions. Here's that word again, of. Of means times, right? It means to multiply. 80% of 25 questions. So 25 is the number I need to work with, but I'm working with fractions, so I'm going to set 25 up as a fraction to make my work easier. 25 is the same thing as 25 out of 1, or 25 over 1. Taking a look at this now. Cross-reducing helps us in the long run, so let's take a look at numbers that are diagonal from each other. 4 and 1, there's nothing that I can reduce there. Those numbers need to stay the same. But 5 and 25, I can definitely reduce those. They both have a common factor of 5. 5 divided by 5 is 1. 25 divided by 5 is 5. Now I just need to multiply across. I have 4 times 5 is 20. 1 times 1 is 1. And just like in the problem before this, anytime we have 1 in the denominator's place, the more simplified way to provide an answer is just to get rid of that, and our answer becomes 20. And this is a story problem that needs a label, just for the sake of writing things out being very difficult using either a stylus or a mouse. I'm just going to leave it at Q. So 20 questions. Is that a reasonable answer? If he answered 80% of 25 questions correctly, 20 questions he answered correctly, definitely. That's a reasonable answer. We arrive at 20 questions. Now let's solve it using a decimal. 80% as a decimal. So here's what we need to think about. 80% looks like 80 out of 100, right? Let's go back to this fraction right here. We read that as 80 hundredths. Once I know that, I can write that really easily. 80 hundredths, I want to show you something though. 80 hundredths looks like this. 80 ends in the hundredths place. But you'll notice with a decimal number, anytime zeros are on the end, all you really have to show on paper, all you have to represent is up to the last counting number. So 80% is the same thing as 8/10. And some of you may have connected this already, but here's an example of what this means. This right here is representing 80 pennies. Okay? 80 pennies, 80 ones. This right here is representing 8 dimes. So both would give you 80 cents, right? We have 80 pennies, 80 ones, or 8 groups of 10, 8/10. Both give us 80. Anyway, so here we go. 80% as a decimal looks like this, 0.8 or 8/10. And again, of 25 looks like times 25. So however you want to set that up, I don't know, maybe I'll put my 25 on top. 25 times 8/10. Okay, so we have 5 times 8, 40. 8 times 2 is 16, 17, 18, 19, 20. The next number that I have over to multiply here is just a 0. I could do that work, but it's just going to give me a bunch of zeros, and I can just skip it. I don't need to do that. I have a number here, but I need to determine where my decimal goes. So I'll go back to my original problem right up here. I have no decimal places here, so I don't count any there. But right here in this factor, I do. I have 1 decimal place. So I go down to my answer. I start at the back here on the right and I count back 1 decimal place. And instead of writing 20.0, there's nothing that really, no counting number that falls after the decimal there. So I can simplify this by just writing 20. And again, we have a label, of course. We're talking about how many questions did he answer correctly. I'm just going to put a Q, 20 questions. You can see we arrived at the same answer. Perfect. Last example, and this is really important because this is the real life application, especially as we're gearing up towards holiday shopping. Not that we're going to be in the stores physically in person a lot, but still there are going to be a lot of sales going on. So being able to calculate the percent off of a original price of an item, super important skill, but also being able to determine what your total cost is of an item after sales tax has been applied. And sales tax is one of those things that is applied. There's a certain percentage of sales tax. So look at this example here. The sales tax rate was 6%. Find the tax on a $12 purchase. Then find the total price, including tax. This is a multi-step problem. Go ahead. If I zoom out, you can see that they've actually broken this down into 2 steps. They said find the tax and then add the purchase and the tax together. So please try these 2 steps together. They're both really important, and unpause your video when you're ready to check your work. Okay, so because I'm dealing with money, I'm already dealing with decimals, and for that sake, I'm just going to solve this the decimal route. This is why it's important to understand how to solve both ways. Sometimes one makes sense more than the other, depending on the problem. So first I'm going to find the tax, and I do that by finding what is 6% of $12. What's 6% of $12? Because that's how much tax is going to be on this purchase. So I have 12 here. I guess I could write this out like this, $12 times 6%. 6% is the same thing as 6 out of 100. If I visualize that fraction like that, 6 out of 100. And then once I visualize that, I can remember that that's read as 6/100ths. So I think about when I'm thinking about decimals, that looks like this. The hundredths place is right here, 6/100ths, right? Okay, let's just multiply. I have 0, 0, 6 times 2 is 12, 6 times 1 is 6, plus 1 is 7. The rest of my numbers here on the bottom are zeros. Again, I could do that math, but it'll just take me a long time and produce zeros. So I'm just going to stop here, and I'm going to determine where my decimals need to go. So looking at this factor right here, I start at the back and I count 1, 2 decimal places, and up here I have 1, 2 decimal places. Altogether, that's 4 decimal places. I start at the back of my answer right here, my product, and I count back 4. 1, 2, 3, 4. So I have what appears to be 0.7200, but I need to consider I'm working with money. So if I'm thinking about this like money and there's a decimal point here, I know that this is the same thing. Let's see. I don't have anything in front of my decimal right here. And in working with decimals, if there's nothing in front of your decimal, you assume that that's a 0 there. So we have 0 and 72 right here. This is the same thing as 72 cents. So the tax on this $12 purchase is 72 cents. That is step 1. They've asked for the tax is 72 cents. This is the next step. Add the purchase and the tax together. This is a really simple one because our purchase was a solid dollar amount with no extra change. Our tax was just a change amount with no extra dollars. We can combine those two mentally and say 72 cents plus $12 gives us $12, and that sounds about right in real life scenario, $12.72. That was a lot of work today and really important work. So I appreciate your patience, and